End-to-end test. Main idea is verify the application, how it's work with real environment. Functional test. We test in isolation. We use fake data. We have almost always no navigation. And for screenshot test, we verify pixel perfectness. We verify components, screens, and ideally we start from design system because design systems later on will be used everywhere in your application. And if you want to achieve efficiency in your tests, you should use all the three approaches. Hello everyone, thank you for coming to this talk. I'm Alex Zhukovic, an Android developer at Backbase. And let's imagine that we have an application, and this application crashes from time to time, sometimes showing incorrect data. And of course, we as developer want to be notified about it before the release, do some fixes, and later on release it publicly. And here UI testing can help. And today we will talk about different types of UI testing, which benefit we can get combining different approaches together. So let's start by example. And here we have a simple create account screen. And when we start thinking about the screen in terms of UI testing, the first idea which we have in mind is, okay, let's try to enter all data, try to create account, maybe try to verify a couple of potential error when one of field is empty. But it's only part of the truth, because what we try to achieve by emulating user behavior, we can call interaction testing, when we try to actually emulate what user can do with our application. The other part of equation is pixel perfectness, because we also want to be sure that our application looks great on different devices, with different font sizes, with different resolutions, with different color schemes. And as example, on these two screenshots, you can see that the name field it's a bit different on two screenshots. So when we migrate from one framework to another, when we migrate from Vue to Jetpack Compose, we want to be notified that part of our UI is broken. So ideally, we want to never publish it to the production. And here you can find all examples of UI tests which you can add to your applications, and which approach can we use for testing them. So, of course, if we want to test how users interact with our application, we will use interaction testing. The same approach we can use sometimes when we test in UI components. If our UI components contains any business logic, which sometimes happens. If not, we can simply verify it with pixel perfectness and double check different states of our UI component. The same we can do with verifying multiple languages, left to right, right to left, different color themes of your application, font size, screen size, etc. And when we double check the permission, we want to use interaction approach here, because when people test permissions, they usually use rules which allow all permissions. But in practice, it's not true, because we as developers want to be sure that our applications works well with all permissions, without all permissions, and when only one of couple permissions are allowed. So ideally, we want to double check all these cases, and here interaction testing is really helpful. And right now, let's take a look at different approaches which we can use and different test types which help us to test user interface on our mobile applications. It's screenshot testing, functional testing, and end-to-end testing. Let's start with screenshot one. So the main idea here is pixel perfectness. So we want to be sure that all our components, or at least the most important components, the most important screens, are rendered correctly on the screen, with different font sizes, color schemes, etc. The ideal candidate for introducing screenshot testing is design system, because it allows us to verify UI components, and in addition to it, we can cover any screens. So we never use real data here. It's always fake data if we want to have some data on the screen. And for screenshot tests, we always should have similar set of data for all the screenshots. The next approach is functional testing, and main idea here is to test your application or your screen in isolation. So we have, usually we have no navigation here. Usually we don't use real data here. We just see that data which we expect to see on the screen are on the screen. This is main idea of functional testing. And in case of end-to-end testing, the main idea is verify how our application interact with the server. And here we have the same as entry point as our application has. So in this case, we truly try to simulate user behavior. We have navigation because usually some features can be far away from the home screen. So we need to navigate through UI to our features, and we have interaction with real database, with a real API, etc. And right now, let's remember how everything started when Android was created. So when first SDK of Android was introduced, we had an activity as an entry point to the application, and it was the main UI component to represent any UI, and still an activity is an entry point to any application. Later on, Google released Android for tablets, and Fragments was introduced. But here was made a couple of mistakes. First of all, quality of the Fragment component and Fragment library wasn't so good. It was good for pretty simple interfaces, but for complex, it wasn't so good. And secondly, we have no good guidance how should we adopt it. As a result, some people just ignore Fragment and continue to create activities. Other people try to decide, let's have one activity and multiple fragments. Other group of people decided, let's have multiple activities and multiple fragments, and it's what you still can find in the project. Its project was created many years ago, and recently we have Jetpack Compose. And Jetpack Compose can be simple UI elements like a button, can be much more complicated UI element. It can be item in recycler view, or it can be the whole screen. So in practice, composable function can be everything except an activity in terms of UI. As we still have all this application, all this component, because I still believe that we wouldn't have fully composed application in next couple of years for sure, especially for a long-lived project. This is why we should know how to test activities, fragments, and composable functions. So let's start with activity. We have activity scenario, which can be launched. We can predefine bundle, and also add this bundle when we want to launch our activity to have predefined set of data. After it, we can also launch fragment in container. It helps us to test fragment in isolation without our main activity. And we have composable functions. Of course, they also should be tested, and ideally in isolation when it's possible. And for it, we have a couple of rules, and one of them is compose test rule. And compose test rule allows us to create to test composable function in isolations. We can test screen, we can test any specific component. Right now, let's take a look at differences between views and Jetpack Compose. So with Jetpack Compose, we have no public ID. We have semantic property instead of properties. And semantic property is much more advanced version of properties, which help us to find any element on the screen. And we have virtual clock instead of real-time clock. So in our test case, we can pause our clock, we can advance time by specific durations, and we will explore which benefits we can get from it during this talk. So let's start with interaction tests. It means type of test when we interact, enter some data, verify some data, and do such type of activities. And right now, let's explore how we can write simple UI test with Compose UI test framework. So first of all, we need to have a rule, and later on, we need to find any element on the screen. To find an element on the screen, we need to use combination of finder and matcher. So the most important part is that this finder will never fail. It can find nothing, but it will never fail. So in practice, you should always have action, like enter some data, do click, double click, etc., or you should assert something. Only in this case, it makes sense to find any elements. Because if even finder with matcher didn't find any element, your test will pass. Because the results can be null, and you don't try to verify anything, you don't try to do any action. And right now, let's speak a bit about different rules which we have for testing composable applications. As we saw, compose test rule, it allows us to test composable function in isolation. However, the main problem of this function for real testing, especially the whole screens, is that we cannot use any string resources. If we want to have access to string resources, we should use Android Compose test rules, which provide access to activity. And if you have access to activity, you have access to string resources. And we also have empty compose test rule. And main idea here that many projects start migration from Vue to Compose. And very often on your fragment, you can have one composable element on the screen. So in this case, you want to launch fragment or launch activity and later on find UI element with Jetpack Compose. So for it, we have empty compose test rule. Using this test rule, you cannot inject any composable code to your test activity. You can also find some elements which is placed on activity or the fragment. And one of really huge difference which we have in Jetpack Compose comparing to Vue is two types of trees. Because with Vue we had only Vue tree, and with Jetpack Compose we have merged node tree and unmerged node tree. The big difference here we will explore by this super simple example. In the middle of a screen we have a button. This whole screen was fully created with Compose. And if we try to use merge node tree, we will see that we have only our window plus our button. This is all what we can see in our merge node tree. But if we use unmerged node tree, we will see that inside button we have image and text. Because as we created this with Jetpack Compose, we know that we created image plus text, wrap it with row, and put it inside the button. And it's really important to know which type of node tree you want to use. Because if we take a look at super simple operation, so we try to find a node by some title. In this case, it's schedule a task. And in this case, as we don't pass any additional parameter to onNode function, we will use merge node tree. So in our case, we will find our button as our component. If we try to do the same text here, we already pass use unmerged tree equals true parameter to the onNode function. And in this case, we will use unmerged node tree. And if we will try to find an element, we will find our text. And of course, if in both of these cases, we double check that our UI element is clickable, in case of merged node tree, our test will pass. In case of unmerged node tree, it will be fail, because our text is not clickable anymore. And if you know the basics, it's super simple to see it in a super basic screens. But when we take a look at more complex stuff, it's sometimes pretty complicated to have everything in your head. So for it, we have a couple of tools which we can use. First of all, it's Layout Inspector, which is part of Android Studio. Unfortunately, Layout Inspector don't allow you to see difference between merged and unmerged node trees, but it already provides enough information about every component and doesn't matter if it's Vue or Composable. And if it's used resources, we also can see it inside Layout Inspector. Another tool which is much more advanced for analyzing merged and unmerged node tree, it's logs. And as you can, it's pretty obvious, but as you can see, merged node tree is much more compact than unmerged node tree. We will explore it. We will zoom in and explore it with more details. But the most important part here, we can use print to log function on any tree, And if we use unmerged tree, we will use unmerged tree. By default, it's merged tree. You can print the whole tree, use onRoot function, or you can find any node with onNode finder and also print to the log, whatever you see. The next super big difference is that in Espresso, you can find only one element. You cannot find a collection of elements. If you find more than one element by your matcher, Espresso will fail. Because main idea of Espresso, you should find unique element and do something with the unique element. In case of Jetpack Compose, we have two types of functions. First one is onNode, with some matcher, which allows you to find a single element. Or you have all nodes, which returns collection of element, and we can interact with any element by index. In addition to it, in Compose UI test library, we have combination of finder plus matcher, and we have functions like on all nodes with text. And if we take a look at this example, and we try to analyze the first row of our application, when we see Americana description and couple of items, we can see that node 11, node 12, and node 13, they are placed in the same flat structure. It means that in the same structure below it, you can see a cappuccino description, etc. for all items. So it means that we cannot really click on the plus item for a specific item because structure is flat. So it's not nested. And when we try to write our test, we think, okay, maybe somehow we can have not flat structure. Somehow we can get hierarchical structure. And in this case, we can simply create any matchers. And we can do it using semantics matcher. And in this case, we can pretty easy create any custom matcher. However, the main problem here is that it can change behavior for our accessibility services. In this example, it's TalkBack. So the main problem of this approach is that our mind tried to give us all examples of tools and approaches which we used in the past. And it was great for Espresso because we had nested structure. But no, it's not appropriate for tools like Jetpack Compose. And the better way, I decided, okay, let me try to analyze UI using accessibility service. Because in any way, we should find an element which is accessible by showing on UI or somehow accessible using accessibility services. And I saw that this button, TalkBack pronounced it as plus button. And in reality, you have Americano, later on Americano is type of the coffee drink, and later on plus button. And the main question here, what does it mean plus button for the user? It means completely nothing. And I said, okay, it's my issue. Let me see how smart people did it in the biggest online shop applications available in Europe. And they did it the same. They don't care about such stuff. Sometimes it's plus button, sometimes it's add button, but really no context. What does it mean add button in this case? So if we try to fix the main problem which we have, and main problem, it's not our test, main problem is accessibility, we add a bit more context. Add Americano to the basket. And right now, when you hear it, you think, okay, it's pretty understandable. And when you do it, right now, it's extremely simple to write UI tests. Because right now, we don't need any custom matchers. We can find our button by content description. And in this case, we fix accessibility issue, and we simplify our life when we write UI tests. It also shows that sometimes we shouldn't try to follow to the known route. Sometimes we try to analyze our problem from different perspective, because the whole idea of Jetpack Compose and how it stores data internally, it's super flat structure. It's have nothing nested, even if we write nested code. Another example how we can create a custom measures. It's when we have a pager component and we want to do swipe. But to do swipe, first of all, we need to find the component on which we want to do the swipe. And here we can analyze using print to log functions. We can analyze our tree, and we can find that our pager has semantic property horizontal scroll axis range. And in this, it means that using our semantic tree, we can find element which has such a key defined. And in this case, we can super simple to find our element on the screen. So if you don't know how to interact with any component, try to analyze no tree, and later on you will find how to use it. And in many cases, you can check a couple of keys. If you need to combine a couple of measures, you can add AND functions after the first measure, and it's you create custom measures which will combine stuff. And right now I want to talk about a huge problem which we have in many educational articles about testing Jetpack Compose is testTag modifier. The main idea here is that using this testTag we can create public ID, which we used to have in Espresso, which we used to have in a Vue. The reality is that if your application accessible, if you can, as a user, see this element, most probably, first of all, it should be accessible, and secondly, it means that if you analyze semantic tree, almost always it's enough information for you, and you don't need to use testTag. If you use it, I recommend to use it only in cases when you cannot find it in semantic trees, because first of all, this element add no noise to your code, and secondly, and ideally, you should check that it will be removed when you build your application. But to be honest, not many people check what happens after they build their application and generated APK or any other type of file. And right now, let's take a look at how can we get string resources in our UI test. So as you can see here, we use Android Compose rule instead of Compose rule. We have access to activity. But in many cases, we don't really want to get access to our main activity. We want to have some generic empty activity and put our composable to it, because it's enough for many cases. We don't want to inject all our dependency just for checking something super simple. So in this case, we can use component activity, and later on, we can inject our function to this component activity. And this rule provide you access here to the activity. When you have access to the activity, you also have access to the resources. It means that you have access to string resources and can find any string resource from your application. Of course, our application is much more advanced than just non-stop using fake data. And we need to wait until we will get some data from the server, especially in end-to-end tests. And here, Compose UI test framework support idling resources, which were introduced in Espresso, and it also have wait until functions, which double checks that our containers with text emotions displayed on the screen, and only after that, next step will be executed. So it's much simpler than implementing idling resources, and in this case, we don't need to connect our business logic with our idling resources, which was needed in counter idling resource. And right now, let's take a look at additional benefits which we can get from the virtual clock. And one of such benefits is testing animations. And here is important now, you don't need to test all your animations, never. You need to test only important stuff. And great example here is many companies who provide application, and this company deliver some packages. And very often you have some beautiful animations, And this animation, it's what users see 80% of the time. After this animation, you will see that your package will be delivered tomorrow, and you close this application or the website. And it's a perfect example because this animation is important, because if after updating you will see no animations, many users can close your application before really waiting until data will be loaded. So such type of animation can be tested. You also can test your animation on splash screen if it's needed. So the main idea here is that we should, first of all, we should pause our virtual clock. It means if it's all-time enable, you cannot guarantee that your screenshot will be taken at the same time. To guarantee this, we need to stop our virtual clock, and we do it with auto advance equals false. And after it, we can advance time by specific duration. In this case, first of all, 100 milliseconds to 100 milliseconds for 100 milliseconds, and in every step, we will take a screenshot. So even if we will rerun the same test multiple times, screenshots will be taken always at the same time, at the same state of activity. So in this case, you can test animation in Jetpack Compose. It's not possible in Vue, because in Vue, we cannot use a real-time timer, and it means that we cannot guarantee that our screenshot will be taken at the same time. So if our UI is static, it will work, it doesn't matter if it will be 500 milliseconds below or after. But if you test animations, it's super important. And if we already started to talk about taking screenshots in testing animation, let's take a look at screenshot tests. So if you try to use functional test or end-to-end test to check the simple scenario, and let's try to analyze the first item. Content descriptions of an icon is similar because icon is the same. Category is also similar, and time is similar. But we definitely see that these two screens are different because timer has some additional padding. So maybe it was done by mistakes. Maybe as a reason of it, it's upgrading library. Maybe it's what we want to have in our application. But anyway, we want to be notified about such changes before releasing our application. And screenshot tests help to do it. So what can we test with screenshot tests? We can test UI components, and we can test the whole screen. In addition to just simple state of a screen, we can check light and dark mode, different font sizes, different screen scales, etc. So here we have all frameworks which are available for screenshot testing. It's Android Testify from Shopify, Dropshots from Dropbox, Paparazzi from Square, Screenshot Test for Android currently from Meta, previously from Facebook, Shot, Snappy, and Paparazzi. And all these frameworks works a bit differently. First of all, some of them require device to start, and they always give you the better results, but they will be slower because they need a device. From other side, we have frameworks which can be executed on JVM. It's Paparazzi and Paparazzi, and we have Snappy, which can be executed as on device and JVM. The main idea here is that even if Paparazzi, Paparazzi, and Snappy can be run as JVM, they work completely differently. So Snappy and Paparazzi use Roboelectric because recently Roboelectric introduced support of native graphics, so it's possible to do such stuff. And Paparazzi use Layout Lib. It's the same tool which is used inside Android Studio for taking preview of composable or non-composable components. And if your component is not rendered inside Android Studio, the same result you will have in your tests. And let's take a look at Shot as the most popular framework for on-device screenshot testing. So here everything is pretty simple, but first of all, just reminder that we need to use the same data every time when we run screenshot test. This is why one of the first line we create our test date, which will be the same for all tests. And every time when we run this test, we will use the same data. Later on, we create our composable test rule. And after it, we can add that our theme will be in a dark mode. We add our component with some test data. And at the end, we just compare a result of our screenshot test. So when you generate first set of screenshots, you will add them to your repository. When we run your test next time, it will compare what screenshot which was generated during test run with golden screenshot from your repo. If we try to use PAPARAZZI as the next, the most popular framework which use JVM, we can see one big difference here. The first one is we create a device inside our test, and it's super big difference, because for the shot or any libraries which require instrumentation test which will be executed on real device or emulator, you need to have agreement inside your team that all people will use the same device, plus you will use the same device on your CI. With PAPARAZZI, you can define screenshot name specification of your device inside test case, and doesn't matter which emulator is created in anyone. First of all, it's not needed, but all your device always will be the same because device is kind of hard-coded in your tests. And later on, you have PAPARAZZI snapshots instead of compare screenshot. So the whole idea is the same here. And here is a couple of examples. How components for the same test renders in two frameworks. Shot is instrumentation test, use device, and PAPARAZZI is JVM. So the first component rendered identically. You can see the difference in sizes for this component, but it's because in one case I was used two different devices. One for PAPARAZZI. It was defined in a test as you saw on the previous screen, and emulator for Shot. And right now you can see that for PAPARAZZI the second component has the same problem as it has inside Android Studio. It's problem with borders. And for Shot, it works great as on any Android device. So this is the main difference. And if we try to think, okay, it makes sense, let's try to have a couple of test cases as example for one component for dark and light theme. And here what you can see is that the name of screenshot is one difference, and using dark theme on light theme is another different. The all other stuff is completely similar and identical. So to solve this problem, we can use parameterized test cases. As we, by default, instrumentation runner is based on JUnit 4, we need to use something to have parameterized test. And it's something is test parameter injector library from Google. So in this case, we just introduce two parameters. One is dark mode, it's Boolean, and font scales, it's enum, which you also can see on the screen. It's manually created simple enum, which have different values for font scale. And later on, use Humcrest to inject these font scale values after the theme. And what is super important here is update your screenshot name, because otherwise, every next test case will override the previous one. So to avoid it, we need to have generic test case name. And after it, 8 screenshots will be generated. So with parameterized test, you can add more and more parameters, and one test case will generate more and more screenshots. Here is small important information. Don't try to cover every font size, every screen scale, because you will store everything in your repo. It will grow super fast, but I recommend to check at least small, default, and huge font size. And if for huge font size it's great, it means that for large it's most probably also will be great. And in this approach, if you will maintain your screenshots for components or screen, you will maintain only one test case instead of maintaining multiple test cases. So it will be much more simple to maintain. And right now, let's speak a bit about efficiency. So, small wrap up. End-to-end test. Main idea is verify the application, how it's work with real environment. Functional test. We test in isolation. We use fake data. We have almost always no navigation. And for screenshot test, we verify pixel perfectness. We verify components, screens, and ideally we start from design system, because design systems later on will be used everywhere in your application. And if you want to achieve efficiency in your tests, you should use all the three approaches. Because if we try to exclude end-to-end test and have only functional test and screenshot test, we can definitely test everything in isolation, find all issues. With screenshot test, we can double check and be sure that from pixel perfectness perspective, everything is great, but we didn't check that our application can interact with latest version of our backend, which is of course the most important thing for the user, at least. If we try to exclude functional test and have end-to-end and screenshot tests, some cases will be super complicated to test. As example, some specific error which your backend can return to you, but it will be super hard to emulate it because your backend works perfectly. So it's super easy with functional test and super complicated with end-to-end test. And of course, if you will have many end-to-end tests and everything will be super slow. And the next thing is screenshot test. If we exclude screenshot test, we cannot guarantee any pixel perfectness for our application at all. And I highly encourage you to explore more about UI testing. I hope you learn at least something on this talk. Thank you.
Thank you, Alex. Thank you very much.